Time travel has been one of the most controversial topics for centuries. We have seen this concept of time travel depicted in hundreds of movies, from Back to the Future to Interstellar. But is it realistic or more of a fantasy? Scientists have indeed found a way to time travel. The concept of time travel was first stated by Albert Einstein during the 20th century. He stated that no object is in absolute rest or in absolute motion, which means that every object on this planet moves relative to one another. What if I tell you that even if you sit down or stand still, you're still in motion? Because you have your foot on Earth and this planet is in constant motion, and further the galaxy is in constant motion. Thus no object ever is in absolute motion or rest. Einstein explained this using the theory of relativity. He believed that time passes at different rates for people who are moving relative to one another, although the effect only becomes large when you get close to the speed of light. This is where things get more interesting. If somebody travels at the speed of light in space and comes back to Earth, probably many years would have been passed here on Earth, whereas the time spent by the traveler would have been only few years. This is called as time dilation. A very well-known example is an astronaut who has spent time on space for over 6 months would have aged 0.005 seconds lesser than us on Earth. Time slows down for objects in motion, while the effect is not noticeable in everyday experience. Which means, to see a significant difference of hours or maybe even years, the traveler should travel close to the speed of light. This might sound like some science fiction movie, but let me explain. The speed of light is the same for all observers, whereas the time is not a fixed unit for everyone. It's relative. We all know that speed is equal to distance by time. The speed of two observers will be the same, but if one has a distance higher than the other, then obviously his time will be longer in coordinating with the distance. Okay, let me explain a concept demonstrated by Professor Brian Cox on his stage time at BBC. Imagine person A moving a torch up and down, and he is placed on a moving machine that moves at a speed of 30 km per hour. We also have another person, B, watching it in a stationary state. The speed of light must be the same for both the observers A and B. But A is covering a longer distance, and also B can examine the fact that he is watching the light trail to cover a long distance. If you accept the fact that the speed of light is the same for both the observers, then how can we justify the scenario? This can be only possible if the time clock of A is slower than B. Sounds pretty amazing, right? Okay, now this leads us to the concept of wormhole. Einstein along with physicist Nathan Rosen suggested the existence of wormholes around 1935. Yet we haven't discovered one till date. Because the technology required to build a wormhole is far beyond our time. The wormhole, as believed by many scientists, is a shortcut through space-time. Consider the wormhole to be like a tunnel. According to Einstein, the wormhole could act like a bridge by connecting one point on the universe to the other point with a shortcut. Imagine a possibility of digging a tunnel at one point of the Earth to travel and slide out of the other rather than traveling around the Earth. Which means you're obviously taking a shortcut. This is what wormhole is all about. According to Einstein, space and time are curved. Say if we tend to accelerate one of the tunnel hole to 95% of light speed and then reverse it back to its original state, while the other end tends to remain stationary. Which means the moving clock would take a slow phase when compared to the stationary one, due to the concept of time dilation. So what's stopping us from building the wormhole? First, acceleration to light speed is going to be a huge task. And secondly, scientists believe that the contradiction of the walls due to gravity might be a problem. So we need something to hold the walls stable inside the wormhole, to hold them from contradicting and smashing the traveler who has taken that path. And that is possible only by providing complete vacuum. Another important concept is that with the help of wormhole, we can travel as far as we want in the future. But it's not going to be possible to date back to the past. Which means you can simply travel back through the tunnel to the time when the wormhole was created, but not far beyond that. Einstein's theory tends to oppose the concept of traveling back in time, but these are just theories as of now. Maybe the near future can give us answers to all of this.